Hello, hello, hello. Hey, can we start, guys? Thanks. All right, so hey, my name is Piotr. I'm with Chronologic. So the topic for today is decentralized automation. It's something that we kind of, we work on this kind of topics quite a lot in the past year. So we are the team that worked and deployed the Ethereum alarm clock protocol to the mainnet last year. So it's kind of near the automation. The clock is something about the time scheduling. I'm going to tell you a little bit more later on. We're going to talk about the topics, and it's going to be also interesting, I think, for the meta transactions and relayers and all that stuff. Okay, so let's get started. It's going to be fairly easy at the beginning. I'm going to ramp up a little bit, more details later on. So let's just start with like a very trivial, Ethereum transaction. So basically, Alice sending one ETH to Bob, right? So what's happening is that, Alice signing and then broadcasting her transaction to, to the Ethereum network. Miners take off, and transaction is getting, after a few blocks confirmed. So essentially, Bob says like, "Hi, I have like one ETH from Alice," right? It's like, I guess everyone understands it as like the basics, complete basics of how Ethereum works. And now we just want to like add a small ingredient into that whole thing. And you might think that's fairly simple, but actually we want to do now something like, hey, I want to send one ETH to Bob, but when, for instance, my balance is something like 2 ETH. Maybe Alice waiting for an incoming transaction from someone else, and essentially want to like forward to Bob, right? And I don't know if I was like pretty surprised when I started with Ethereum like a few years ago at the beginning, that actually there is no way or possibility to schedule a conditional transaction or a time-based transaction on such a thing. I mean, this is pretty straightforward. Typically, like when you look at the Linux kernels, this kind of things doesn't live in the kernel space. They live like outside in the user space. So I can imagine like Ethereum doesn't have the opcode for like delayed transaction or like conditional transaction, something like that, right? So let's take a look how we could build that kind of thing without actually changing the way Ethereum works today. So as I said before, Alice want to send one ETH to Bob, but only when some sort of condition is met, right? So what she does is like sign and let's say store this transaction along with a condition. So condition in this case is Alice balance is like greater than 2 ETH, right? We need to introduce some sort of like a node or agent. I'm going to call it agent, like further on. It's not like a Ethereum node or Ethereum agent in the network. So it's something else, right? But on a very high level, this is something that is going to watch for the condition, and if condition is met, just publish or broadcast the transaction to the network. That's like the easiest possible way to do that, right? On a high level. So you may want to ask like why we want to do that at all, and actually there is quite a lot of use cases for such a thing. It's this is pretty much the same picture that was on the previous slide, but this time we want to send to someone like a smart Bob. It's in fact a smart contract, right? And we are not going to query for my balance, for the Alice balance, but we're going to actually set a condition for a smart Bob, state. So we represent that as a smart Bob state is, greater or equal to 2. I know it's like fairly high level, but we're going to specialize this a little bit, more later on. But pretty much the same setup. We have an agent going to look for this condition, like execute and test the condition against the network, and then execute the transaction to the smart Bob. And you might ask, who's the smart Bob? And there is actually quite a lot of use cases. The smart Bob, you can see is like a MakerDAO CDP, for instance, and you want to build a the conditional transaction that is going to be launched. Let's say when your liquidation is just nearby. So, you don't want to take a risk and want to like, top up your CDP, for instance. The other use case, which is like really like big, and that's what we also exploring like recently, is all sort of OTC trading. And this is because basically, OTC trading is very often about the future, assets, future tokens, and this is like a paper agreement, like, legal agreement between some people. And if someone gets some tokens, it has to be like, like forwarding those tokens to the destination. And this actually, idea of having this as a conditional transaction is fairly, relevant for these people, and also because you can actually show, in some ways that this transaction has been scheduled and is going to be executed when the condition is met. It's also like a additional like intent for the person who is waiting for this transaction. And obviously, another use case is something that we built as well, is a scheduling transaction, so Ethereum alarm clock. It does actually do the same thing as I showed you, but the condition, in fact, is a time. So, I want to send the transaction, but I want this to be executed like tomorrow, maybe 1 year from now. So this is essentially, it's pretty much the condition. The condition is tested against a timestamp on a smart contract or the block number or what have you, right? Okay, Cdp monitoring, that's already mentioned. Yes, stop loss take profit features for the decentralized exchanges. That's really interesting thing that we've been, exploring, and actually some of my colleagues delivered some working things, not yet like finalized, but one of the problems we see with the decentralized exchanges is that you can't really do a decentralized way of doing a stop loss functionality, because essentially you would need to trust someone to execute your transaction. And we talk a lot about the decentralization, and so why centralize certain things, right? Yes, and not the last, but the one from the list is the state channels watchtowers. It's also, the watchtower is the idea that it helps, it is like essentially a availability manager for the state channels, right? So one of the assumptions of the state channels is that both parties should be online, in case of any like, fraud or something like that. You need to be online to prove that, the state submitted by your counterparty is wrong. When you are not online, then you just hit the timeout, and essentially, you will lose basically, even though you were right. So, the state channel is like a third-party service watching the states and just reacting. It's like an insurance or data availability provider. So, okay, let's talk a little bit about how we could build such an agent, right? So on the previous slides, agent was like a very high-level thing, and I'm the engineer, so for me was the first idea was like, hey, let's just code the EVM contract that is going to hold the condition and execute the transaction when the time comes, or when the condition has been met, right? Yes, of course that's doable, and that's part of the reasons we also build the Ethereum alarm clock, is that who is going to execute, who is going to trigger this transaction, right? As you know, smart contracts are pretty much reactive, so you need to have like external trigger to something to just happen, right? So it's not going to happen like by themselves. So the question is like, who is going to trigger this at the right time, or when the condition is met, right? I'm going to talk quite a lot about that later on in this presentation. So the other maybe issues or not is, the contract essentially becomes a message sender, so kind of the owner of the transaction, which means like this kind of contract that is relying this transaction is also your identity. You can imagine that you want to like sell the CryptoKitty, okay? But the owner of the CryptoKitty is your private key account. And now if you want to like delegate this and use this through this proxy contract, then the transaction is being sent by the proxy contract, which is not the owner of the CryptoKitty, which is a big problem, essentially, with many, many integrations on the Ethereum. And I think anyone who actually launched a mainnet protocol on Ethereum knows that even though the coding of the smart contract is not really, I mean, it's hard, but it's not like the end of world, but there's a lot of time and things and trust and everything required to just make people use your smart contracts. So you do like audits, like formal verification, a lot of stuff. Essentially, what I'm saying like it's very expensive, and not everyone basically can just do that, right? This is like a very, very big limiting factor for these smart contracts in the end. All right, so let's say what's the other way to kind of build that stuff, right? Let's not use the EVM. Let's just see how could we build like I call it like Web 2.0 agent. It's not like 2.0. It's not anything about the content, but it's just to highlight kind of the way you could build that if there is no like decentralization concerns at all, right? So that's fairly easy on the other hand, because you need like some API, a database, and some sort of workers that, on a block level or maybe every 10 seconds just query the condition and then post the transaction. So even though this looks like pretty terrible if you are in the decentralized world, it's actually pretty convenient, because here what happens is that what's going to be stored on the database is actually pre-signed transaction and the condition. So pre-signed transaction is just like Ethereum transaction. Like you can imagine this like this wallet sending a transaction to Infura, right? So it's pre-sent transaction. Infura, only bad thing that Infura can do with your transaction is not to execute it, not to include into the network. But that's probably like in most of the times there is no incentive to do that for them, right? So pretty much here you have the decentralized way of signing and publishing transaction and storing. What is really centralized in this kind of solution is the execution, right? So so our company is responsible for like querying the conditions and in the end sending the transaction. But we can't do anything with your signed transaction basically. It's like immutable, right? So, some of these characteristics of this kind of approach of building a centralized service that is like kind of glued to the decentralized world is obviously cheap, no identity issues, no funds custody because that's your transaction that is being sent. Yeah, but it does require trust for the execution part. So, I'm gonna now focus on how to build and how to design the network of those executors so we gain trust, and I'm going to show you how we did for the Ethereum alarm clock as well. So what we want to decentralize, obviously we want to remove the friction of the trust for the execution. Accountability, it's because if you schedule a conditional transaction, it might be more beneficial for the executor to not execute. Let's see, this is like a very high paying or big transaction on the decentralized exchange, right? So maybe someone is dumping my token, so I better not execute that, right? So here we're gonna talk how to bring this accountability and trust, and also reliability. I mean, it's not necessarily we talk about the peer-to-peer networks, which tends to be in theory more reliable than the single networks, but in when you use just AWS and other cloud providers, in most of the cases they just work, right? So it's not a big concern here. So yeah, so that's pretty much the same, the same image. What we're gonna do, we're gonna build a network of these kind of executors, and it's no longer one company running the nodes. It's every one of you can run a node and provide the service. And I mean, this obviously is very valid for the current, meta transaction trends. As you saw, and that was presented on the previous presentations, at the moment, everyone just focused on the UX part. No one really focusing on the decentralization part of the meta transactions. And thus, they just run the node, right? But as I said, the baddest thing they could do is just withhold the transaction. Although meta transaction doesn't carry any conditions and a time scheduling, which is completely different thing, of what we're doing. All right. Yeah. Let's basically take a look at this. So before we kind of start talking about this decentralization of the relayers network, we gotta need to build like some sort of vocabulary so everyone understands, what I'm talking about basically. So delegated execution, it's that's the pattern or like the idea that someone else is going to execute your transaction in exchange of some sort of bounty or incentive, right? So it's like miners including the transactions into the blocks. They just get paid your transaction fees on top of obviously the block reward. Like in the long run, when we just like in the Bitcoin space, when we just mine every single Bitcoin, the only incentive for running the network would be the transaction fees, right? In Ethereum, that's pretty much depends. But that's like the idea, right? And then all of a sudden, when you have this, delegation in place, so you said like, I want my transaction to be executed, and I just give you like, 1 ETH for the reward, and I don't really care who is going to execute that. Because, I don't really care because that's gonna be from my contract or from my address, right? So all of a sudden you are incentivizing multiple parties to join this sort of network. So the network or the execution market is actually being formed at this time, right? So, we have this network because anyone can execute your transaction in this idea. Anyone can join and anyone can run the node. So what we essentially ending up with is a market where we have the executing agents which just provide the service, and the bounty. So like the rewards are on the demand side of the equations. And that's fairly that's pretty important because the network won't exist if there is no bounties for the execution, and also no one's gonna wanna delegate the execution if there is no running nodes, right? So that's important to build this kind of network. And also, if you're more into the economics, this is pretty much some characteristic of the perfect competition market. So those executing agents, they provide the same service. Everyone provides the same service. Everyone have the same access to the information. And also that means that on the long run, probably the rewards or the profit is going to be very marginal, because everyone's going to be competing, to just run as cheap as possible their node, so they can provide as cheap as possible service. It's going to be like reliability versus the cost of running. And that's how basically Ethereum alarm clock works. So we have a community running a bunch of nodes. They are incentivized by people scheduling transactions. And it works without without us basically. So I think that's really important for the meta transaction in the next step in the few months or whatever, time, that they basically gonna get into a decentralized market. So it's gonna be freely for everyone to run the node and maybe earn money on top of whatever. Obviously there is quite a lot of, now we talk about the execution markets, that's decentralized and open. There's a lot of stuff that, have to be taken into the account. So, let's talk about the bounties. So is it one-time bounty or maybe a subscription? Or you want to get paid with either ERC20 token, maybe NFT, or maybe actually on the biggest abstraction, it is just the pay to code kind of thing. So, I execute your transaction, you execute, and I then execute the payment transaction. So if you abstract this into the code, then it can be the reputation boost maybe is more important than fractional amount of Ether. Or maybe I want to get paid with NFTs because that means something for me. I don't know. So what I'm saying, that's something that we worked a few months ago. It just tries to capture and generalize the problem of the payments. This obviously could be used for incentivizing the miners, but that's really huge change, so probably not a good idea. Storage. Just quickly go with the storage. So if you have the conditional transaction, one of the problems with that, and that's not the problem with the meta transaction because they don't have any conditions, right? Is that you don't know when the condition is going to be met, which means that in the worst case, it could be like hang forever, right? Like you say, like I want this to be executed when my balance of Ether is like 10 millions of Ether, right? It might never be true, hopefully not, but maybe. So we gotta store this transaction somewhere. So there's like some of the options: EVM storage, EVM events. EVM events is like a really hacky way to use the advantage of the storage of the Ethereum, but not really using the EVM if your smart contract doesn't need that. I mean, you can, or IPFS swarm, you can then just put the payload back to send the payload with all the queries to the smart contracts and then compute, right? So it is possible today to like almost entirely skip the storage on EVM in many cases. All right, conditions. So yes, EVM state and plus testing functions, EVM events, and obviously, like in the long run, oracles that are delivering some sort of information from the outside world. That's going to be really huge, for the conditional execution. Yeah, one of the biggest problems is that if you have this network, is that how we be sure that someone should execute and didn't execute, right? So here there is a work that we do on the EVM state proofs, which means that you can have like other network participants proving that you should execute and you didn't execute, so you're withholding essentially the transaction, and you get this like a challenge period, stake-based, slashing conditions, all the stuff very similar to the Plasma and other constructions. Yeah, obviously, last part is going to be about the coordination. So one of the problems with such a network is that, to kind of settle or get the consensus who's going to execute your transaction. Essentially, if you just put let's say, the request into the wild, then unfortunately that's not a zero-sum game. So, if someone wanna send the transaction on the Ethereum, and then 10 other nodes follow the same transaction, so only first one is going to be successful and the other one's gonna fail. Okay, so what does it mean? That all these like 9 remaining transactions gonna take a cost, like minus whatever amount of money, and only the first node is going to get like reward. So this is pretty bad because it's not sustainable way of building a network. That's why there is quite a lot of ideas how you can just build a coordination or consensus essentially in such a network. Random election, like beacon chain kind of thing. Auction based, so you wanna like do some interactive protocol on settling the amount of reward that you are willing to execute, and then whoever is going to asking that can just pick the cheapest one or whatever, or can look at the reputation based. So yeah, that's pretty much it. I mean, there is not really like a kind of ending thing. I want to show you that going from decentralized 2.0, Web 2.0 agents into decentralized is quite a lot of work, and then there is quite a lot of discussions, I guess, that many people will have whether this is like worth to decentralize everything or maybe just do a partial decentralization. That's something that's probably we get an answer in the future, I guess. Yeah, so this is like a little bit of the things that we did, and the clock is now into my Ether wallet. Probably released today, maybe tomorrow. I think they merge our pull requests at night today. Yeah, and other solutions that we work, and the time node network, which might be suitable for the meta transactions as well. So yeah, thank you. There's a bunch of links that you can just follow us and see our work and etc. Okay, thank you, and questions. Yeah. All right, I guess that's it. Thank you. Oh, one question. I mean, Yes, I mean, we have the automate tool which just automates the execution. So actually you can execute any transaction, any payload transaction to anything. So you can build on top of that like CDP or something like that monitoring. If you ask about that, maybe I didn't. Okay.
And what happens if I create state-based condition for the transaction, and then some executor picks this transaction up and sends it to the Ethereum whenever a condition is justified, and then I just front-run that transaction and change the state of the product?
Oh yeah, for sure. That's definitely one of the attack vectors on such solutions. Yeah, I mean, for sure, the front running is always like a threat for this kind of like competition, between the nodes. There is some sort of like, what we, for instance, have in the clock is that we give a window of time for the execution. So, because in other words, if you said like, I want this transaction to be executed at exact block, then it's probably not going to happen because it's fairly hard to kind of, snipe this, good time to get included into that given block. So you want to like relax those conditions. So in this kind of case, the state probably might be like, valid, and that's what we're looking at, has to be valid for like 5 blocks or 10 blocks, and then it's good to go. And if it's like, or actually you can have like additional conditions, so it's not exactly a amount, but it's like a range of amounts. So, in like 0x idea, it's not like I want to stop condition at this price because it might be hard to, in the decentralized manner, to just, guarantee the execution. But if you want to say like relax that and you allow for some range of the values, it's fairly easy then to do that. Thank you.